5G is talk of the town everywhere across the globe. Most of the focus is on 5G radio, also referred to as new radio in standard term. Much of 5G talks are around millimeter waves for new radio, which brings the 5G a real power to fulfill ITUT 2020 requirements, like ultra-low latency and very high speed in the order of 10 to 20 GHz. Despite of 5G radio, to accommodate the need of 5G services and use cases, 5G Core is also being reimagined. 5G Core provide a significant paradigm shift in its architecture, in terms of complete separation of control plane and data plane. In previous mobile systems like for 2G and 3G, control and data both were residing on a single plane, and specific interfaces and transport were used to communicate it between different nodes and propagating the data through them over same plane. 4G systems, which harnessed the power of internet for transport and separated the control plane to offload certain functionality to a central node at its core. 5G is following same shift and bring it in more robust and separated way for control and data plane. It also address the access stratum and non-access stratum as well in more explicit way. 3GPP technical requirements document sets out the requirements for 5G Core or next-gen core. It identifies two representations of the next-gen architecture, a point-to-point architecture and a service-based architecture. Point-to-point architecture view could be seen as evolution of EPC Evolved Packet Core System. It provides separation of control plane in much explicit way. The functionality of access management and session management is separated out for better access control, fast connection responses and network selections. Session management is more associated with policy control functions and application functions. This may help to provide a unified policy control and large-scale convergence at access. With the complete separation of control plane, it provides centralized authentication and a unified database that will be helping the system to bring a unified core irrespective to access technologies. In service-oriented architecture view, we find the same functional nodes, and even the same interfaces like N1, N2, N3, etc. The difference here is that almost all the control plane functionality is mounted on microservice architecture, or as service-oriented architecture. In this view, instead of predefined interfaces between elements, a services model is used, in which components query a network function repository to discover and communicate with each other. Here a separate entity function as NRF. This is closer to the cloud-native networking concept, where various functionality will be implemented as virtual network functions. This model is more akin and conducive to flexibility and adaptability in the system. For more insight on 5G, subscribe to our channel, XGN Lab, a research and knowledge wing of Funtar Communication. Thank you.